Hi class, in this video I'm going to take you through the solution to the practice exam that we did in our lab for midterm 2. So on the exam you're going to get something that looks very similar to this. It's going to be an exploded assembly, and our job will be to assemble it correctly. And what you'll see is that if we look on the assignment, I'm not going to give you a whole lot of guidance, so you're going to have to use a lot of your intuition. But what I will do is point out specific things that really need to be met. So if we take a look at the instructions, we're not given much on how it comes together, but you can see, and so you will at least be able to see where everything goes. So I'll give you something like a section view so you can see how the components come together, but you'll see every single component. And then I'm going to clue in on important things. Like, for example, this vice grip sliding jaw is going to move with the lead screw. The lead screw is going to be rotating and translating through the lead screw collar. And that's going to clue us in to how this is assembled. So let's kind of go through this. So the first thing I might want to do is take a look at stuff that is fixed. And if I look back on here, what I can see is anything that is threaded tightly and screwed in, it's probably going to be a fixed connection. So I think these plates are probably fixed. And then the screws right here are probably a fixed connection. And then I've got a set screw going through the base to this collar. And if you zoom in, you can kind of see there's a flat here. I'll show you that when we get there. So let's go ahead and do all of the fixed connections first. Oh, I also have another fixed connection that I can do. Is probably these end caps for the uh, bar here. Those are probably fixed in because they were screwed in. So that's going to be a fixed connection as well. So let's go ahead and do all those fixed connections first. I'm going to do J for the joint tool, but just so you know, it lives under the assembly. I just like to do J because I don't have to navigate there. Okay, I'm going to first actually just put these plates. Doesn't super much matter the order of operations here, but I'm just going to connect them rigidly to the vice jaw as they would go. Now technically the bolt's going to make it a rigid, so in theory you could do a planer and then a constraint between the bolt and each component, but that's a little bit overkill. So I'm just going to go ahead and put it in as a rigid constraint because I know it's going to be. I'm going to take this, and in my joint tool, I'm going to actually look at this counter bore or countersink. I'm going to put that right flush with the bottom of the other part of the countersink. Uh-oh, it's going the wrong direction. That's okay, I can just click the flip option. Just so you know, the motion I've been doing is rigid. The animation will give you this kind of angry, it's vibrating back and forth. Okay. And so that's how I would do it. I'm going to just continue to go and add all of my joints like so. So I'll go ahead and make a joint in between here and here. And feel free to skip ahead in the video if you're like, okay, I understand the screws, but I'll just go ahead and add them all in. That one I didn't have to flip. That's kind of nice. Make another joint between this plate and my base. Oh, and actually, before I go any further, I was told I should ground the base so it can move. And I don't want it to move. So I'm going to go ahead and click on the base. I don't want to lose any points, so I make sure I ground that. You should see a little pin next to it, and I can't drag it around, where everything else I can drag around. Okay, so I'm going to go ahead and continue on with my joints of my screws. Flip that one. Okay, gonna join this screw. Flip that one. Okay. I've also got this little plate right here. In the section view, I can see that it goes to the sliding jaw. And I want to make sure my countersink is facing down so that when I put my screws, it's going to go. Notice that this is actually has been modeled with some clearance, some allowance. That is because this is a fixed fastener application. So you would want to control the tolerance of this threaded hole with a projected tolerance through the depth of this part because this is a fixed fastener application. So that gap is by design. Okay, so I'm going to go ahead and join this here. You can choose that joint origin, that's just as fine too. Flip. Okay, and then I saw that these balls here are going to join to the end cap, so I'm going to go ahead and hold control. So if I hover over that inner surface of the cylinder and control, I can select that point. So if I don't, I'm not going to get that point, I'll just get the origin. So if you hover over surface, hold control, then I can get that point. I know that that's going to go to right there. That looks nice. I'll repeat that. Holding control so I can select that joint origin. Oh, wrong direction. I better flip it. So if I click flip, I can flip that. Okay. And then I've got a couple more fixed connections. I know that there's a joint between here and my base. Okay. And I'm going to do something. I'm actually going to make a construction plane, a mid plane between this face and the corresponding face on the other side. So that mid plane is bisecting my model. That's because my origin was shifted. Okay, so I hide my origin. I've actually been hiding my joints because there's so many of them, but you may want to toggle them on and off as needed for clarity. So I'm going to hide them for now. I'm going to do a section view, and I'm going to use that construction plane that I just made. And then I'll go ahead and hide my construction. Section views are really helpful for doing these assemblies. And the reason I'm doing it is because I want the hole, this threaded hole for the set screw, to line up perfectly with that flat part of my collar, and it does. So I'm in good shape here. But if it didn't, I might have to rotate this joint origin so that it does line up nicely. Okay, so that looks good. I'm going to turn off my analysis. So hide my analysis. I'm going to now join that set screw. So I'm going to join, and I'm actually going to put it all the way into the top right here. Okay. Let's just go turn back on the analysis and make sure we don't get a conflict. Nope, actually I've got a nice flush face right there. That's great. Okay, turn off my section view for now. And I've actually finished all of the fixed joints, at least the obvious fixed joints for now. And you'll see, I don't see any more threaded holes, but looks like there's an extra screw in this assembly. I accidentally put in one too many screws when I was inserting the components in the assembly, so I apologize about that. I won't give you any extra on the exam, so everything should have a place for the exam. Okay, so the next thing I need to do is start to do the assembly, and as it is things that are not going to be a rigid joint. And so I see that my lead screw is free to slide and rotate. That's going to key me in that the joint origin that I'm going to want here is cylindrical. So J for my joint. Doesn't really matter the origin, but I'm going to do the threads, the male threads of my lead screw into the female threads of the collar. And so I insert that. Now it's showing the wrong motion. So I need to go to motion, and it's not revolute, it's not slider, it's cylindrical. Okay, so that looks good. So now it's free to rotate and slide in the collar. And then I've got to actually decide how am I going to join the sliding jaw to this lead screw. And it's not going to be fixed. If you think about fixed, this wouldn't be able to spin without this also spinning. This should actually be free to rotate in it. So I'm going to go ahead and join. And I'm just going to go ahead and let's do the end of the lead screw. And let's put it as deep as we can into the hole. So holding control so I can select that joint origin. Okay. And then I'll press OK. Actually, I'm going to reverse the order. So I'm going to do the first one is here because I want to move it to the lead screw. So if you select that one first, it'll move it to there. I'm going to flip the direction, but then I'm going to change the motion to a revolute. Okay, so now it's free to spin. I'm also going to use my section analysis. So I'm going to turn that on before I just move on with this joint. And what I noticed, if I turn on my section analysis, is that the hole for the pin that's going to go through here, they don't match, and it needs to match. So what I'm going to do is move my joint origin. So I can just kind of drag it into place. And now they're aligning nicely. Okay, so now my revolute joint looks good. Turn back off my section analysis. And what I notice is as I spin this, my sliding jaw is rotating. And that's because I haven't fully constrained it yet. There's actually another constraint. This face should not be lifting off of that face. So I need to apply, I'm going to capture position. I need to apply a constraint. So I'm going to do joint. If I look at the motions, it's not rigid because it needs to slide back and forth. It's not revolute. Potentially you could use slider. So I could slide this in there. I'm actually just going to go ahead and do planar. And I'm going to select this face. It's going to want an origin. So you have to actually select, hover and select an origin. It's kind of arbitrary. But so we're choosing planar as our motion. And so now, as I spin this, it's not allowed to move off that face. Okay. Do some more joints, and I'm going to go ahead and join this shaft in here. And I could do cylindrical, but I'm just going to do slider. Technically cylindrical would work, but I'm just going to make it a little bit simpler on my assembly. Sliding will get the same effect here. So now I can slide that back and forth. And the very last thing I need is this lead screw pin here. So I'm going to join that. To the midpoint right there. So I held control to get that. This might be a press fit. Slider would work, and I would accept slider, but I'm just going to go ahead and go rigid because that's just going to be a press fit. So if I look back on my section analysis, what that is doing is it's going to allow this lead screw to spin, and this groove is going to hold it in place so that the sliding jaw has to move back and forth, advance back and forth with the advancement of the lead screw. So kind of a clever mechanism there. Okay. All right. Everything is assembled and joined, except for this screw. So sorry about that. But it looks like we've added all of our joints. What we haven't added is that this can have a conflict here. We don't like those conflicts. So I'm going to go ahead and also look back, and we saw that we are also supposed to do something that where our model functions mechanically like it would in real life. So we know that the lead screw should translate a 0.5 millimeter for every 360 or every full revolution the lead screw makes. So let's go ahead and add that in right now as a assembly, and that's going to be a motion link. The link could be between this cylindrical joint, and I could actually do the same joint. So it's going to go half a millimeter, and I had to type in 0.5 for every 365 degrees it rotates. Now, I'm going to drive this joint. One thing that you notice here is like when I added that, I'm not actually able to freely move this around. It's kind of a little bit hard. That's because the rotation of this has been linked to the advancement. So it might be a little bit easier to drive this joint. So if I drive it, let's see if it looks correct. So we know that if we're threading the screw clockwise, that's like tightening a screw, so it should be advancing it. And it looks like that's correct. As I righty go to the right, it's advancing it. So that's good. So we've chosen the right direction. Otherwise, we just need to flip that relationship. Okay. And then what I need to do is I need to set up a joint limit. So to do that, I'm going to go ahead and align the faces to see where the limits are going to be. So I'm going to align in between these components, a line between this face and that face. Click OK. And I'm actually, it's not doing it. And I'm like, what is going on? Remember that when we added this motion link, it kind of constrained things for us. I'm going to actually, for now, I'm going to suppress this feature. So if you right click on it and I unsuppress, you can just suppress it for now. So it's not acting right now. When it's suppressed, then it's going to make my alignment a little bit easier. So I go back to my modify and align. I'm going to basically align these two faces. Oh, oops, and it didn't work. And it didn't work because I forgot that the base here is grounded. And since this is rigidly fixed here, then I didn't get, this isn't allowed to move. So the order of operations matters on the align tool. So first you want to select the from and then the to. So I'm glad I actually did that wrong so that we can see. I need to select this one first and then align it to that face. Okay. And then what I can do now is I can look at my cylindrical joint. So I can click on that. I can actually drive the joint. If I drive the joint, I see that its position is 3.52. So I might just write that down on a piece of paper right next to my exam. So 3.52, I'll write that down. Okay. And then I'm going to do another alignment. The limit of where this would stop going through here is if these two faces are aligned. So I can go repeat the align tool. Oh, not the drive joint. So go to modify, align, and then I want to move from this face to that face. Okay. And if I look at that position, I can actually see it kind of easily. It's negative 26.48. So negative 26.482. So those are going to be my joint limits. So to enable those, I'm going to go back to my cylindrical, and then I'm going to edit joint limits. The minimum should be the negative number, so I'll do negative 26.482, and then I wrote down my maximum was 3.52. Okay. And now, let me see, did that enable? Oh, my motion was wrong. So one thing I noticed was, that didn't work. So I'm actually glad I made that mistake, because then it points out a mistake that you might make. So I go back to edit joint limits. I need to cancel. So on my cylindrical, I'm going to go to edit joint limits. I need to change the motion. I was going a little too fast to slide. So actually that rotate, I'm going to undo those limits. because it's the slide that needs to be negative 26.482, and then my maximum being that 3.52. It should have keyed me in because the other one had the wrong units. Okay, so now when I move this back and forth, I can't move it past that. And it looks like I might have got my negative one wrong. Did I type it in wrong? So my cylindrical. I did. I typed in 25 and not 26. Okay, so now it's actually I'm simulating the joint limits. Do not, whatever you do contact sets. It'll crash your Fusion. Okay, so now I'm going to also put the motion limit on this so that it can't translate out. And the align is going to be a little bit harder to do on this one because it's like a weird tangency face here. So I'm going to say, at least for this exam, is like just as long as you just get it close enough. So I'm going to like kind of come in and say like, oh, that's pretty close. So I got 29.661. So I'm going to go with 30. And then if I go the other way, oh, it's about negative 30. Okay, so it looks like 30 to 30. So on that slider joint, edit joint limits, the motion, there's only one motion for a slider, but minimum will be negative 30. And then we'll set our maximum to 30. Okay, so now we can move it back and forth. So it's simulating where the end caps would limit it from going through our lead screw. Okay, now I'm going to unsuppress my joint link, my motion link. And actually, I've fully done it except for this annoying screw right there. But so now, as you rotate this, and it's kind of hard to do because it's sliding here. So it actually does move, but it's a little bit hard to freely do it. So I might just go ahead and drive my joint just to make sure that it has the motion that I want. So I'm gonna, as I rotate this, okay, that's good. Or even if I translate this, what you see is, so as I rotate that, it's translating. That looks good. Okay, so I've actually, looking over, I'm gonna like one more time review this. I've grounded the base. This piece moves with the lead screw. I've got this rotation and translation, and I've got this sliding down. Let's take one more look at our section view just to make sure, double check that. So maybe take a look at our section analysis and make sure that looks correct. I'm going to turn off my joints just so I can see it clearly. And it looks pretty good. See, my screws are all in the right part. So I'm pretty happy with this. I think I'm ready to submit it. So I'd save it into my exam folder. Okay, hopefully you found this video helpful.